Hello, students. So, once again, the paper was a very easy one, and more weightage in this question paper went to quantum mechanics in section A. As you can see, two questions came from quantum mechanics, one from laser, one from diffraction, one from EMT, another one from optical fiber and superconductors. Section B, as we can see, more weightage went for interference unit, then quantum, EMT, and laser. Very less weightage in this paper this time went to superconductor and nanos, where they just gave one question here and one numerical from the superconductor sections. So interference and diffraction unit got more weightage along with quantum mechanics, laser and optical fiber, where optical fiber was less, laser, Einstein, helium neon, etc. was more. EMT was very less, and more less was superconductor and nano. So this 70 mark paper, as you can see here, on the whole it was very easy. Now let us solve this question paper. So let us begin with section A. Section A, the questions were of 2 marks each, and they were compulsory questions. So you have to think before giving answer for a 2-mark question. First question was from the unit laser. What do you mean by population inversion? So it will be better if you would have drawn these diagrams. This could have carried 1 mark easily and 1 mark for the line that an excited number of atoms in the excited state is greater than that in the ground state. Okay, Wein's displacement law, as usual from quantum mechanics, one law does come in every paper. So Wein's displacement law describes the relation between the temperature of a black body and the wavelength at which it emits most of the radiations. And for this formula, lambda m, that is the wavelength associated with temperature T, is equal to Wein's displacement constant. You will get your good 1 mark. If you want to draw the diagram, well and good. Otherwise, this much explanation along with what the symbols hold, you get your marks. Okay, next, define dispersive power of a grating. So if you would have written dispersive power, definition is ability to separate light of different wavelengths. Along with this, if you would have written this formula and explained what each symbol meant, that is A plus B is grating element, N is the order of the spectra, and d theta by d lambda the dispersive power, you will fetch your full 2 marks. Next, this numerical, it is a very easy one. See, it is of skin depth, and skin depth numericals are usually straightforward, where EMT wave, you have been given the frequency as 10 megahertz. So you will have to change this megahertz into hertz, is incident on a good conductor with conductivity given to you and relative permeability given. So you have to find the skin depth. So the formula for skin depth is under root 2 upon omega mu sigma, where del is skin depth, omega the angular frequency, and mu the permeability of the conductor. So omega is 2 pi f. We put the values, and this 10 to the power of 6 comes from megahertz. So you get the value of omega. Mu is mu r into mu naught. Here you have been given mu naught as equal to mu r equal to 1. So 4 pi into 10 to the power of minus 7. Keeping these values, the skin depth comes out as del equal to 0.000655 meter. So 2 marks, I think 1 mark you can easily fetch for the formula, and the other 1 mark for the correct answer. What is de Broglie wave for a moving particle at temperature T? Again, quantum physics. De Broglie wavelength, either numerical comes or the definition. So you can use the formula for de Broglie wavelength, lambda equal to h upon under root 3 mkt, where h is Planck's constant, m mass of the particle, and k the Boltzmann constant. Show that perfect diamagnetism is an essential property of superconductor. That is, they are talking about Meissner effect, which you have to mention. And mathematically also, you can show that B is mu naught into H plus M. H is applied magnetic field. M is the magnetization which is produced within the specimen, and B becomes zero because of the Meissner effect. So you can see the susceptibility becomes negative, which is showing the diamagnetic behavior. Okay, this numerical on optical fiber, it was also very easy. A fiber made of silicon with a diameter of core is such that it consists of core and cladding. Refractive index you have been given. Numerical aperture formula is refractive index of core in under root 2 del, where del is equal to refractive index of core minus refractive index of cladding upon refractive index of core, which you have been given. So numerical aperture answer comes out as 0.28. Usually numerical aperture answers are always less than 0.5. Okay, now we come to section B. The condition of maxima and minima in reflected light in a thin film of uniform thickness. See, they are asking you a 7-mark question where you have to tell about condition of maxima and minima. So first you will have to derive the equation of path difference. You can make this diagram self-explanatory if you want to skip out the detailed explanation, because your question is concentrating on maxima and minima. So the diagram is necessary with a small self-explanation. Then your concept of path difference for the reflected ray from the upper and lower surface. Once you reach the path difference formula after applying Stokes' law, because it is a reflected light case, you can easily fetch 4 marks, 4 to 5 marks, and then apply the condition of maxima intensity where path difference should be n lambda, and the minima intensity where path difference is equal to 2n minus or plus lambda by 2, and give this expression. Differential form of Maxwell's equation. This is a very straightforward question. You can easily fetch your marks. There are 4 Maxwell's equations. The second one is a very easy one where there is no derivation. You just have to show that magnetic lines of force are closed curve. That will fetch you just 1 mark. The other 3 Maxwell's equations can be of 2 marks each. See, the first one is Gauss law of electrostatics. Second is the Gauss law of magnetostatics. Third is Faraday's law of electromagnetic induction. And fourth is modified form of Ampere's circuital law. Construction and working of helium neon laser. See, 2 to 3 marks. Obviously, first you will mention what helium neon laser is, and if you make a good, well explanatory diagram, so 2 to 3 marks there, then this energy level diagram also should be there if you want to get your full 7 on 7. But make the diagram a self-explanatory one where you are showing that it is a gaseous laser with helium neon, how the atom is getting absorbed because of collision, always population inversion is maintained, and then the spontaneous emission and the laser transition and helium neon. And you can show this, you have to show this diagram also, because they are saying construction and working. So both should be there. In the end, you can mention 2 applications for your full 7 marks. Look at the question. Derive the expression for diameter of dark ring in Newton's ring. So here they are asking you to derive an expression for the diameter. So you don't need to explain Newton ring. You just have to explain how the formula comes for diameter of ring. So you make this a ring. You show that the whole radius is r. So this becomes 2r. T, the thickness of the film, 2r minus t is this much difference. Then you apply the property of circle and you make this formula here. T is equal to r square upon 2r. Now for dark, see till this diagram and till here, you can get 3 to 4 marks easily. And the dark ring case, equate it equal to condition of minima, that is n lambda, and you get the answer. And if you want, you have time, you can just mention that it decreases with increasing order of the ring. Davison-Germer experiment diagram should again be a very good self-explanatory one. What was the purpose of conducting the experiment? To explain the existence of matter waves. So you can get your 3 to 4 marks here easily, and then you explain this diagram, that where the bump occurs, at what angle and at what potential difference, and because of this the wavelength due to the Davison-Germer experiment, that is de Broglie, and the Bragg's formula, it comes out same. So no doubt it is lengthy, but see, important is this diagram. Why was this experiment conducted? To explain the wave nature. In short explanation of that diagram, these curves are very important because they tell about the wave nature. You don't need to show this calculation so lengthy. You can just show that lambda came out equivalent either through the matter wave concept, that is de Broglie, or through the Bragg's equation. And this proved the existence of matter waves. So this will fetch you your marks. Then construction and working of an optical fiber. Define the term C, construction and working. 4 to 5 marks. Acceptance angle, numerical aperture, and relationship between them. So you divide your marks around, say, I say 3.5, 3.5 this way. So what is an optical fiber? Consisting of core, cladding, and buffer coating. Acceptance angle, numerical aperture. Make this diagram, show the acceptance angle, show the numerical aperture. For deriving a relation between them, it is very easy. You just show this angle and then the numerical aperture formula. That this is acceptance angle, N1, N2 are refractive indices of core and cladding. Compton scattering. Why it is not observed in visible light? Because the scattering is so less, though it is there, because it is so less that it is not observed. Now they are saying derive change in wavelength in Compton scattering. So for change in wavelength in Compton scattering, you will have to make this diagram and this formula. You will have to show the scattering process. You will have to show that incident photon, target electron is at rest, and the two laws. One is law of conservation of momentum, and the other is law of conservation of energy, or this formula. Put the values here and you get this expression for del lambda. Now, why it is not observed? Because this shift is less than 0.001% of the initial wavelength of visible light, which is undetectable. So for this point, you can get 1.5, 2 for this diagram, which is explanatory, and this formula. So this is how the 7-mark breakage is going to be there. Relation between Einstein coefficient, laser question, that how much atoms are absorbed equal to spontaneous plus stimulated, how much are the atoms there, and then simple, you apply the Boltzmann law of distribution of number of atoms and Planck's equation, equate it to that, and you get the expression for relation between Einstein coefficient. This is easy to fetch marks because there is no diagram, no detailed explanation here. State and proof pointing theorem, it is very important. It comes approximately every year, pointing, which is telling us about the energy of electromagnetic wave. So you write Maxwell's third equation, Maxwell's fourth equation, multiply the third equation by H, multiply the fourth equation by E, subtract them, apply the formula of curl, and use the relation B is mu naught H, D is epsilon naught E, and you get the expression, which shows the rate of transfer of energy into electromagnetic field, and the pointing theorem. Fraunhofer diffraction of light at a double slit and obtain the condition for diffraction and interference maxima minima. So either single slit comes or the double slit diagram should be there, where you are showing the two slits, S1, S2, the formula for resultant intensity, and then how this changes for the double slit. Explain these factors, that this is representing the intensity due to individual slits and this is due to the n number of slits, and you can show in short the maximum minimum. Maxwell's equation discuss transverse nature of EMT waves and explain how they are oriented with respect to direction of propagation. So in vacuum or free space, this condition you should write first. This will give you your 1 to 1.5 marks. Then you write the Maxwell's equations, how they are changing in free space. And then you can tell about these expressions and in short, just explain the transverse nature. Don't go in for such a lengthy one, just this much, that they are here transverse. Newton's ring, why are they circular? Very common question asked in Viva also. Newton's rings, why are they circular and what are Newton's ring? So geometry of the air film formed between a plano convex lens and plain glass plate. Okay, this numerical, the diameter, this is also a very easy numerical. Newton's rings are observed in reflected light of wavelength 55900 angstrom. Diameter of 10th ring is 0.5 centimeter. Find the radius of curvature of the lens. So I have kept it centimeter only. dn square is equal to 4n lambda r. So r is dn square upon 4n lambda. Values given I have kept and I am getting the answers 105.93 centimeters. Next, monochromatic light of wavelength 600 nanometer. So this nanometer has to be changed to meter or change it to angstrom. That will be a better option for you. Is having at what angle? So a plus b sine theta is n lambda. Theta is sine inverse n lambda upon a plus b. 1 upon a plus b is 5000. N is 1, lambda is 600 nanometers. So this 1 angstrom is 10 to the power of minus 10 meter, lambda is 6000 angstrom. I put these values and approximately I am getting my answer as 18 degree. Okay. The superconducting transition temperature of lead is this much. Initial field is, so Hc is equal to H naught into 1 minus T upon Tc whole square. I put my values and I get the answer as 33.728 into 10 to the power of 3 ampere per meter. What are nanomaterials? Nanomaterials are substances with at least one dimension measuring 100 nanometers or less. They exhibit unique properties. Then definition of nanomaterial, 1.5 mark. Concept of quantum dot, quantum wire, quantum well will fetch the other marks. Do draw this diagram so that it becomes clear what is quantum dot, what is quantum wire, what is quantum well. Okay, Meissner effect, this diagram. And for type 1, type 2 superconductors, try if you possible with this table, it becomes very clear the type 1 superconductors and type 2 superconductors. So on the whole, I think it was a very easy paper. Thank you.